Let me today solve the two JEE problems. There are many more which will be solved in the coming days. These two problems come under the topics quadratic equations. Before solving, I'll just try to give you a brief idea about what is a quadratic equation, or what is the meaning of the roots of the quadratic equation, and some of the properties of the quadratic equation. Now, a quadratic equation is written as ax squared plus bx plus c. This is a quadratic equation in the sense that it is an equation in x of degree 2. So when this is solved, solving I will not do. When this is solved, you will get the values of a as minus b plus or minus b squared minus 4ac divided by 2a. So these are the two values. You see that it is minus b plus and minus b minus. So there are two values because it is a quadratic equation x, and x you can assign two values for x, in the sense that if you assign the value of x here, left hand side will become 0. So that is the meaning of saying that solving the equation. Now, so these are called the roots of the equation. There are two roots. X is equal to minus b plus square root of b square minus 4ac divided by 2a. That is one of the roots. And another root is minus b minus square root of b square minus 4ac divided by 2a. So these roots, because if you substitute in the place of x, left hand side will become 0. That is why we call as roots, and we can call them also critical points. Okay. Now, here we particularly call this b squared minus 4ac as discriminant. Call the discriminant because it is going to discriminate the roots of the equation. Here you see that the roots of the equation, this b squared minus 4ac, if it is equal to 0, this value is equal to 0 means then the roots of the equation are distinct. Example, a simple example I will give you. It is x squared minus 6x plus 9 is equal to 0. Now you apply this, x is equal to minus b plus or minus b squared is how much? 36 minus 4ac is 36 divided by 2a, that is equal to 6 by 2, that is equal to 3. That means 3 is a root. 3 is not only a root, again it is a root, in the sense that since it's a quadratic equation, this is a quadratic equation, there should be two roots, and both the roots are distinct roots 3, and therefore if the discriminant is 0, then the roots are distinct. Now you can very well see this. This is nothing but x minus 3 whole squared. X minus 3 whole squared means x minus 3 into x minus 3. So either x minus 3 is equal to 0 means x is equal to 3 or x is equal to 3. Therefore the roots are distinct here. So understand that this is discriminant. If it is 0, then the roots are distinct. Then the next is if the discriminant is positive. That means what? If it is greater than 0. If it is greater than 0, the roots are real. The roots are real. Say for example, I will give you this. Real in the sense that they can be any number of a real number. A real number. For example, I will give you this. See, x, I will take this, x squared minus 5x plus 6 is equal to 0. X squared minus. Now you see that this is nothing but if you apply x is equal to minus b plus or minus b squared is 25 minus 4ac is 24 divided by 2a. So this is 5 plus or minus 25 minus 24 is 1. So 5 plus 1 this is so this is equal to 3 or it is 2. 3 or 2. So this is, so what is that will have? X minus 3 into x plus x minus 2 is equal to 0. Actually speaking, if you factorize this, you will get this. That means what? See, b squared minus 4ac, this is greater than 0. 1 is a positive number. Therefore, you get two roots which are real numbers. The real numbers in the sense it can also be negative also. For example, I will give you another example. See, just take this. See, for example, x squared then minus x plus 6 is equal to 0. So this can be written as x minus 3x plus 2, this one. So x is equal to minus b plus or minus b squared is 1 minus here it is working. Let me see whether this is x squared minus 3 x plus 2, it is minus 6, this is minus 3 plus 2 minus x. So you see that x is equal to how much? X is equal to minus b plus or minus b squared is 1 minus 4ac is plus 24 divided by 2, that is equal to how much? 1 plus or minus 5 divided by 2. So this is equal to what? X is equal to plus means 3 and a minus means minus 2. So this is nothing but what? X minus 2, x plus 2 into x minus 3 is equal to 0. So you see that here the roots are real. They may be, one may be negative, one may be positive, but the only thing is that roots are real. So this is the case when greater than 0 this happens, and when it is less than 0, then you will get only imaginary roots. Imaginary root means the roots will be of the form a plus ib. If a plus ib is a root, then it will have two roots. One root is a plus ib and another root will be its conjugate a minus ib. So when it is less than 0, we get imaginary roots. So these are some ideas about the roots of the equation. Now, if you are given, let us suppose that you are given alpha and beta are the roots of a quadratic equation. Let us suppose that alpha and beta are the roots of a quadratic equation. Then we can write the quadratic, because I do not know what is that quadratic equation. I know only the roots of that equation. So what I will write is, it is x squared minus alpha plus beta of x plus product of the roots. For example, let us suppose that you have got two roots, 2 and 3. How will you write this equation now? X squared minus sum of the roots is 5x plus product of the roots is 6 is equal to 0. So x squared minus 5x plus 6 is equal to 0. That is my equation. So the roots are nothing but 2 and 3. So this is how we write. And it can be extended for higher degrees also. For example, let us suppose that you are having alpha plus beta plus gamma are the roots. Alpha plus beta, alpha comma beta comma are the roots of a cubic equation. Then you can write this as x cubed minus x squared into alpha plus beta plus gamma plus alternatively plus minus minus plus minus, like that it goes on. Plus minus plus minus. Now here you have taken alpha, taken one at a time. Here you have to take two at a time. Alpha beta plus alpha gamma plus gamma beta. So this is how you take the next. Then next one is what? Minus, you will have it as alpha beta gamma, all taken at a time. So when you have three roots, then the way to write is x cubed minus x squared into taken one at a time plus x is taken two at a time minus the product of the roots is equal to 0. So this is how we write the equation. Keeping this in our mind, let us pause on to the first problem here. I'll explain how the first problem is done. So this I will do. Now you see that it's a fourth degree equation. The given equation is a fourth degree, but it is given that the critical points are minus 1, 0, 1. Minus 1, 0, 1 means you are the roots of the equation, and it is only there are three roots. So, but the given equation is of the fourth degree. Now, if you differentiate a given equation, for example, let us suppose that your f of x is equal to x to the power of 4 plus x squared plus 2x squared plus 2. Then if you differentiate with respect to x, it will become a third degree equation. It will become a third degree expression, and if it is an equation equated to some constants. So you see that if f of x is given like this, then if you differentiate it once, it will become a third degree. So if you differentiate twice, it will become a second degree. Keep that in your mind. Let us discuss this problem. Now this is f of x. So the f of x is a fourth degree, but given roots are nothing but the three roots are there. So the equation should be a third order, that is third degree equation. So I will write, so let f dash, it is not f, let f dash of x is equal to it is equal to, the f dash of x, it is equal to, I will write it here, it's a fourth degree. Now the f dash of x will be equal to, if the roots are known, then I can write this as x minus 0 into x plus 1 into x minus. So this is the equation. This is equal to 0. So f dash of x is equal to, so f dash of x, now, so you have got this, this is my f dash of x, this is my f dash of x. Now if I want to, this is an x fourth degree polynomial, but this is a third degree polynomial, and the roots are 0, 1 and minus 1 and 1. Now f dash, this constant is put because it can be 1 also. You have to find that necessarily that constant, and that constant may turn out to be 1. That is, let us not bother about that. Now the meaning of this is d of f of x divided by dx is equal to k into x into, I'll write this as, I'll take everything inside. So you see that this x squared minus 1, and this we take this x cubed minus x squared. This is what you'll have. Now you cross multiply d of f of x, you integrate on both sides, k into x cubed minus x squared, you integrate on both sides, because dx we multiply, integrate. D of f of x is what? It is your f of x. So plus a constant. So this will give you k into x to the power of 4 minus this by this, and plus a constant. So this is what you will have the answer for this. So what is my fourth? Now I am able to get the fourth degree. I am able to get the fourth degree expression here. So is f of x is equal to, I have got this. Now this you see is a constant. Now let us come to the problem. Let us come here. Now keep this. Let me rub off this. Now you see that here it is given that there is a set. Now we are going to discuss about this set. There is a set T in which for every element x belonging to R means set of real numbers, it is f of x is equal to f of 0. This is the property. Whatever x you are going to take, f of x will be equal to f of 0. That is the property of that particular set. Okay. Now here you see that the elements are taken here. We are going to take the elements that we are going to find, they are going to be here only. That is why he is asking. The elements that we are going to here, some elements that we are going to get, they are going to elements of T, for which the property is f of x is equal to f of 0. That is the understanding. Now here I will write here, given for all x, f of x is equal to f of 0, x belonging to R. So it is given. We are given like this. Now what I do here is, I will call this as your 1, put x is equal to 0 in 1, put x is equal to 0, 1, put x is equal to 0 in 1. So what will happen here? F of 0, this everything is 0, f of 0 is equal to c. F of 0 is equal to c. Now you see that, so this 0 happens to be an element here. Understand that 0 is an element there. Now f of x is equal to f of 0, but f of 0 is equal to c. So this will imply that f of x is equal to c. F of x is equal to c. So what is the value of f of x here? C. So I can substitute, therefore 1 becomes, so this 1 will become, in the place of this you put c. C is equal to k into x to the power of 4 by 4 minus x squared by 2 plus a constant c. Now you can, both are equal, same constant, so cancel both sides. So this will give you what? So this will give you k into, I will write this as x to the power of 4 divided by 4 minus 2x squared is equal to 0. So you can cancel this. So k by 4 is not equal to 0. K is a constant, it cannot be 0. So k by 4 is not equal to 0. So k by 4 is not equal to 0. So this implies x squared into x squared minus 2 is equal to 0. X squared. So this implies either x is equal to 0 or x minus 2 is equal to 0. Okay, x is equal to 0 already we have got, x is equal to 0. So x is equal to 0 or x squared is equal to 2 equal to 0. Therefore x is equal to 0 or x is equal to plus root 2, x is equal to minus root 2. Now you see that this plus 2 root 2 minus root 2 or 0, they are nothing but elements of what? T. See, all these elements belonging to T. all these elements belonging to, that is why he has given critical point, the sum of the squares of all the elements of t. Here we have got the elements of t. What is the element of t here? Root 2 and root 2, and root 2 into root 2, say what is that? Sum of this. You add these three, square them and add. So what will happen? See what I'll rub off here. See, given. See, I'll write here your 0 root 2 minus root 2 belong to t, because it belongs to t because this property is true. Okay, therefore this. Now because f of root 2 will be f of 0 equals 0, something like that. So you see that using that you'll have 0 square now, 0 square plus root 2 whole square minus root 2 whole square is equal to 0 plus 2 plus 2, that is equal to 4. So what is that you are having? Answer is 4. So this is how this problem is done. Let us pause on to the next problem. So this problem is over. So this problem is over. I will rub off this. Now I will come to this problem. This one, see, you are having x squared minus 3x plus b is equal to 0. See, alpha, beta are roots. Alpha, beta are roots. Therefore, alpha plus beta, see what is alpha plus beta? Here in the place of alpha plus beta you have got 3. Therefore, what is that? See, x squared minus 3x plus b. So what is the value of this alpha plus beta? Alpha you can write like this. So this is equal to, I have taught you in the beginning itself how to write the equation when the roots are given. So alpha plus beta is equal to 3 here. And what is your alpha beta? Alpha beta is equal to p. And what is that? X squared minus 6x plus q is equal to 0. This implies gamma and delta. See, this implies gamma plus delta is equal to 6 and gamma delta is equal to q. So these are all very, very important results that we are getting here. So these are the results that we have got here. Now what is here asked said is that what is given in the problem is that alpha, beta, gamma, delta follow geometric progression. That means this implies if alpha is one root, another root is k alpha, because k alpha divided by alpha is r. Another root is k squared alpha. K squared alpha divided by k alpha is again k. K is the common ratio. And another root is k cubed alpha. K is common ratio. So k. So there must be a common ratio for writing a geometric progression. So alpha, k squared alpha, k cubed alpha. So these are the 4 roots of the, that is, these are the 4, that is k alpha and k alpha are the roots. You have the first one, and k squared alpha and k cubed alpha are the roots of the second one. This is as per the problem. Now let us come to this. Now what is your 2q? 2q plus p. What is your 2q here? 2q is, your q is what? 2 gamma delta. See, gamma delta plus, what is this p? P is alpha beta. So this is equal to 2, write it in terms of, because it's geometric progression, write it in terms of alpha. So what is that? K squared alpha and k cubed alpha. So you will get it as k to the power of 5 alpha squared plus, what is this? In the place of beta, you write it as what? Beta is what? K alpha. So this is your beta, this is your gamma, and this is your delta. So in the place of beta, you write it as k alpha, you will get k squared alpha. So this is equal to, take this, yes. Here what is the common thing that you are getting here? You are getting it as k squared is there. K squared into alpha into, it is 2k cubed plus 1. Okay, 2q plus p. 2q plus p. 2q is what? 2q is 2 gamma delta and alpha beta is P is alpha beta 2 k to the power of L squared plus k squared alpha. So k squared alpha can be taken outside. So you will be left with 2k cubed. Here k to the power of 5 alpha. Here it is k squared alpha k alpha k squared alpha. So what is it? You'll have. We should not commit mistakes in this. K squared alpha can be taken outside. So it is 2k cubed plus 1. It is 2k cubed plus 1. Okay. Then we'll see what happens. Now, what is your 2q minus p? So your 2q minus p will be equal to k squared alpha into 2k cubed. It is minus 2qp. 2q, okay, no problem, it's good. So 2k minus 1. 2k minus 1. Now, what is your 2k? I'll write it here. 2q plus p divided by 2q minus p will be equal to your k squared alpha into 2k cube plus 1 divided by k squared alpha into 2k cubed minus 1. So this will be left with k squared alpha, sorry, this is it's not required, 2k cubed plus 1 divided by 2k cubed minus 1. Now, let us do the small simplification here. Now, alpha plus beta is equal to what? Your alpha plus beta, we have alpha plus beta is equal to 3, which implies alpha plus k alpha is equal to 3. Therefore, alpha into 1 plus k is equal to 3. Okay? Then, here, yes. Then, another one is gamma plus delta is equal to 6 implies gamma is k squared alpha plus k cubed alpha is equal to 6. So k squared alpha into 1 plus k is equal to 6. That is k squared into alpha into 1 plus k is equal to 6. K squared into, what is alpha into 1 plus k? Alpha into 1 plus k is here, it is 3 is equal to 6. So this implies k squared is equal to 2. K squared is equal to 2. Now what is that you are having here now? Here I think here I have committed a mistake here. You have to prove that 2q plus p, 2q minus p, it is 2q plus p. 2q plus p is, here it is 2k squared k cubed, k to the power of 5. Here alpha into alpha is alpha squared. It is k alpha into, here I have a thing, it is k into, because this is alpha into k alpha. So this is k squared alpha. So this is your k squared alpha. This is k alpha squared. It is k alpha into k alpha is k squared. So this is equal to 2, don't take this 2, k alpha squared into 2k to the power of 4 plus 1. See here, I have written it wrongly here. Alpha beta means here, alpha is alpha, k alpha, so k alpha squared, take this k alpha squared outside, so you'll be left with what? K to the power of 5 squared, k squared, so this is what you'll have. So in the place of this, so this is wrong, so similarly, what is it you'll have? So this is, you'll have it as, here you will give it as, it is k alpha squared into 2 to the power of k minus 1. Now this is a small mistake that I committed, so we have to be very careful in doing the simplification, otherwise we'll get it wrongly. So 2q. Now what is that you are having now? So you are having the results as it is. See, I'll write it here. So this is nothing but, what is that you are having here? So 2q plus b will be equal to your, see this result, k alpha squared into 2k to the power of 4 plus 1 divided by k alpha squared into 2k to the power of minus 1. See, these two will get cancelled, leaving you with what? 2k to the power of 4 plus 1 divided by 2k to the power of 4 minus 1. But we have found, see, I have done this simplification, alpha beta is equal to 3. So I have written it as alpha into 1 plus k is equal to 3. Gamma delta I have written here, k alpha k squared into 1 plus k is equal to 6. But I will write this as k squared into alpha of 1 plus k is equal to 6. But alpha into 1 plus k is equal to 3. So we have got the value of this k squared is equal to c. Substitute, I'll write it, call this as sum A. Call this as your A. Substitute in A. Substitute the values in A. So what will you have now? So you will have it as, so this is equal to 2q plus p divided by 2q minus p is equal to, in the place of k squared you put as what? You put this, you put k squared is equal to 2. So it is, you would have 2k to the power of, okay, whatever do you get. So it is 2 into k to the power of 4 is what? It is k squared is 2, so into 4 plus 1 divided by 2 into 4 minus 1. So it is 9 by 7, which implies that 2q plus p divided by 2q minus p is equal to 9 is to, I'll write here, is to 2q minus p is equal to 9 is to 7. So you are given here, it is 9 is to 7. So this is the answer. So this is how we solve the problem here. The only thing that you must understand is what is the meaning of a geometric progression. Otherwise you see that here the only simplification. There are a lot of problems like this in the quadratic equations. Still more difficult problems are there. As and when time comes, I'll be in a position to solve those things for you. Thank you.